There's also something called the Great Conveyor Belt, which warm water moves north and then sinks in the Atlantic and then returns back to the equator underneath. And that's another thing that we've discovered fairly recently that we now understand. In fact, the ocean moves most of the heat that hits at the equator.
Deep water currents circulate for the same reason that ice floats. Seawater is most dense right before it freezes. This allows cold water to sink and spread along the sea floor. You wouldn't learn about these complex flows to look at a standard map. On it, the world's water is a bright blue blank. To form a more complete map, an underwater robot called Alice is programmed to descend 3,000 feet and chart mid-depth currents.
Well, there's really no way that a human being can go down there and stay there long enough to make any measurements, so all of our measurements of deep ocean currents are really made indirectly by instruments. We believe that the Alice allows us to go to places where there aren't ships and make measurements in seasons where no sensible sailor would be there.
Alice is just a little heavier than the surface seawater, so it sinks until it is balanced by denser water below. At regular intervals, an onboard microprocessor tells Alice to rise from the ocean depths and report its underwater movements.
Alice is kind of an elaborate drift bottle. We all remember throwing bottles in the ocean with notes in them, and some people have even seen their notes come back. Alice is a kind of an elaborate version of that that floats at the surface, sinks to depth under its own control, drifts along for a number of days, and then rises itself up to the surface and talks to satellite.
The information that Alice transmits is entered into a computer map of the world's oceans to predict more precisely just where things will go when they go with the flow.
Of course, they carry almost anything that ends up in the ocean, but some of the more important things are pollutants that we put in the ocean, and so there's extensive study of, for example, how radioactive waste being put into the Atlantic is dispersing through the Atlantic. The question of how the nutrients that eventually support the fish and other living things in the ocean, how that circulates through the ocean, where the carbon dioxide goes. You know, as we're producing more carbon dioxide by burning, some of it is accumulating in the atmosphere, but a lot of it is going into the ocean, and the question of where that goes eventually is intimately tied up with the currents that carry it there.
Are the ice caps melting? Is the planet getting hotter? Will sea level rise? The answer to many global warming questions lie in the sea.
I think one of the real worries about the future is, A, is global warming really happening, and if so, B, the effects on the ocean will be large. What can we do to live with those effects?
Global warming is hard to detect because weather is usually unusual. It is difficult to distinguish what is occurring naturally from the result of human activity. We know that modern humans are producing huge amounts of CO2 by burning fossil fuels. We don't know how much of it is absorbed by the sea. There are some things we know with certainty. Currents circulate water around the world, and whatever happens to be in them goes along for the ride.
If you are in the current with a lot of plankton and have smooth sea and completely blue sky full of stars and all the plankton glittering, then you have a feeling you're sailing on a magic carpet. That makes you really feel that there is a universe. You forget it when you live in a big city and have the walls around you. The ocean is moving all the time, and it is beaming with life down below. So when you get close contact with it, you have a feeling that you have an enormous friend forever.
Wind is air in motion. As it hits the ocean's surface, it bends water into waves, pushes currents, and fills sails.
Winds are a lot like people. Wherever you go in the oceans, there'll be places that have their own personalities. So if you're down in Hawaii and you're on Maui and you're looking back towards Los Angeles, the trade winds just keep blowing at you day in, day out. They'll be 20 miles an hour and they really push hard on you. Those are pretty steady, persistent winds.
Different parts of the ocean have different winds. Some places are gustier than others.
Here we are, Southern Ocean, dripping stuff this is. Roaring 40s into the 50s. Here we go again, whoa, 25 knots, how is that?
These boats are sailing in the Whitbread, an around-the-world race that covers a staggering 27,120 miles. Icy gales constantly lash the waters near Antarctica. The Southern Ocean is a 5,000-mile stretch of open water between South America and New Zealand. The combination of the sea's immense span and consistent winds make mountains of water. Winds are created by the sun's heat. When one part of the world is warmer than another, a difference in pressure is created. As the hot air rises, the cold air flows in across the Earth's surface to replace it. This movement is wind. As the sun beats down, it heats up the air, which expands and rises like these bubbles. As they heat up, they move faster and faster. Cooler air moves to fill in the gap left by the rising hot air. This movement is a basic law underlying winds and currents.
Second law of thermodynamics says that heat will flow from hot to cold, and you can't stop it from doing that. And so this redistribution of heat, which is one of the main functions of the ocean in the Earth's climate, it's not something that you have to worry about. It's gonna happen.
Long after the wind has died, the waves it created roll until they hit the shores. A wave is a pattern in flowing water. Water molecules do not move forward with the wave.
The motion of the wave isn't the same as the motion of the water. And you know this, because if you're out there in the surf and a wave comes by, you bob up and down. You don't go, the wave goes into the beach, you go up and down.
Those who have had first-hand encounters may have another explanation.
My definition of a wave, it's a moving palette of ocean energy that invites us as humans to ride along and participate in that movement, that flow of energy. The waves are always changing. Riding a wave is, it's dancing with the ocean's pulse, with its mystery. It's like playing music with the ocean.
Surfers can ride the ocean because as the waves near the shore, the bottom of the wave drags on the sea floor and slows down compared with the surface water. The top of the wave then topples over and breaks on the shore.
If you watch a wave coming in when it's far out at sea, I mean, it has this kind of up and down motion. If you could look and just sort of lock onto one little bit of water and watch what it was doing, it would be making this kind of a little elliptical thing. As the wave gets close to the shore, it like stubs its toe, is one way, or it gets stuck on the bottom. And eventually what that leads to is the breaking of the wave.
Each day, the tug of the moon and sun creates tides. The ebb and flow of tides can be as small as a few feet or span more than 50. The moon pulls on all the water on Earth. It tugs at the ocean as much as it does a shallow pond or the water in a glass. The height of the tide varies, depending on the size, shape, and the depth of the water basin.
When you have this situation of the moon pulling on this side and then pulling the Earth away from the ocean on the other side, it looks like you've got a bulge where the ocean is sort of football-shaped and the Earth is baseball-shaped inside. And then that moves around the Earth and follows the moon.
Twice a day, tides rise and fall, and waves constantly lap our shores. The ocean's waters shape the coast and create our beaches. It is the most common view of the sea, and usually our first.
My favorite thing is just to pick up a handful of sand and just look at it. Every sand grain is different, you know, different color, different shape, you know, they all, and the reason is, of course, this is stuff that's been brought in by rivers from the whole headlands, or whatever drains into that ocean is bringing little bits of rock and stuff down. And so the sand is sort of a portrait of the whole back country.
Sand, like water, is in constant motion. It is a visible example of the ocean's energy at work.
So if you think of the beach being this way, the water's washing the sand grains up like this, but then when the water runs down, it runs straight down. It doesn't go back the way it came. So each little sand grain is sort of doing this kind of little sawtooth zigzag. And if you go to a beach, you can actually see this. You can watch the grain go up and you can watch it come down. If you just work that out and say, how far could a grain move? I mean, in a month, it could be a mile down the beach. And in fact, one way of thinking about beaches is that it's a big conveyor belt that's moving stuff down beach.
All along the beach are dynamic expressions of force. The free rides never stop.
Surf conditions along city beaches are as follows. Surf at Ocean Beach, 1 to 2 foot there, 2-4 safe. Surf at Mission Beach.
Humans are the only animals that willingly put their lives in jeopardy to break records. Pepin Ferraris holds the world record for the deepest breath hold dive. On March 10, 1996, he went 428 feet in 2 minutes and 11 seconds. A former spear fisherman from Cuba, he combined his natural ability with meditation techniques to push his physical limits.
If he kept going, eventually you'd get to a point where you literally would be crushed. I know at depth you can crush steel, so you can certainly crush the human body.
Scientists have always believed that unprotected, the lungs of the human body would implode at about 500 feet. Pepin thinks he can reach that depth and live.
Come on, please come here.
To go deeper, we need armor to protect us from the sea. With the assistance of diving contraptions, we have descended to the deepest point in the ocean. On January 23, 1960, the United States Navy sent 2 men, Lieutenant Don Walsh and Swiss engineer Jacques Picard, on the 7-mile trip to the bottom. No one has ever been back.
There wasn't a whole lot of time to dwell. I mean, there's no soliloquies and observing a fish or the moon or the stars and wondering these great cosmic thoughts. It was just head down, tail up, hard work.
The deepest part of the ocean is called the Challenger Deep. It is located about 200 miles southwest of Guam at the bottom of the Marianas Trench.
Probably the principal concern we got on the dive site, 2 of them. Where is the deepest place? Because we didn't have any maps or charts to tell us where it was, except in a very general way. And secondly, how much stuff had broken or fallen off on the tow out.
Once they reached the Marianas Trench, the exact location of the Challenger Deep was found by utilizing a basic echolocation technique.
We used hand grenades. And we, I think, cleaned out every hand grenade they had on Guam. I know we had to get resupplied. A tugboat came out from Guam and brought us more hand grenades. And we would put these in the water, and when they the hand grenade went off. We could hear it on the underwater hydrophone, and then we start a stopwatch. And because a hand grenade puts a lot of energy into the water, that explosive charge, we could hear the return signal from the bottom. And thus, 7 seconds was deeper than 5 seconds.
The bathyscaphe Trieste was designed by Picard's father, Auguste Picard. He was a pioneering balloonist who used the basic design of the air balloon and applied it to the construction of the Trieste. Balloons float because they use a gas that is lighter than air to rise through the atmosphere. The Trieste had buoyant tanks that were filled with air and a substance that was lighter than water so that it would float. That substance was gasoline, 32,000 gallons. To descend, the divers released the air from the tanks so the Trieste would sink. And at 9 a.m., the Trieste slipped beneath the surface. But at 20,000 feet, something went wrong.
We had a problem at 20,000 feet where a window cracked, and that gave us kind of a start. It made a hell of a bang.